Right now, underneath your skin, something may have already started. No pain, no mark, no warning. The damage is invisible, happening at a scale so small that no mirror will ever show it to you. And yet, this is exactly where skin cancer begins. Not in a doctor's office, not in a scan, in a single cell, and a single strand of broken DNA. When sunlight reaches your skin, it carries more than warmth. Embedded within it is ultraviolet radiation, UV light, invisible to your eyes, but not to your cells. UV radiation comes in two main forms. UVB is the shorter, more energetic wave. It doesn't go deep, but it hits hard. UVA travels deeper into the skin layers and is also emitted by tanning beds and sun lamps, devices that many people assume are safer than the sun. They aren't. Your skin's outermost layer, the epidermis, is the first target. Packed inside those cells are trillions of DNA molecules. Each one is a precise instruction manual telling that cell how to grow, when to divide, and when to stop. UV radiation can interfere with those instructions directly. Here is what actually happens inside that cell. DNA is made of 4 chemical bases. Think of them as letters in a long instruction code. When UV radiation strikes, it can cause 2 of those letters to fuse together incorrectly, creating what scientists call a pyrimidine dimer. It's a misprint in the code, and it changes how the cell reads its own instructions. Hundreds of these errors can form in minutes under direct sun exposure. Most of them happen silently. And this is where the story either ends or continues. The human body is not passive. The moment damage is detected, repair systems activate. Specialized proteins scan the DNA strand, locate the misprint, cut it out, and rebuild that section correctly. It happens constantly, quietly, without you ever knowing. In most cases, it works. The error disappears. The cell continues normally. But your body has a second option when repair fails. It can instruct the damaged cell to self-destruct. Scientists call this apoptosis. It sounds alarming, but it's actually protective. The body eliminates a dangerous cell before it can cause harm. Both systems, repair and self-destruction, are your skin's defense against what comes next. But in some cases, neither system succeeds. A cell carries unrepaired DNA damage and survives anyway. One key reason this can happen involves a gene called TP53. It acts like a gatekeeper, detecting damage and deciding whether a cell should be repaired or destroyed. When UV radiation damages this gene itself, that gatekeeper is silenced. The cell doesn't know it's broken, and so it does what cells do. It divides. One damaged cell becomes 2. 2 become 4. Each division copies the same flawed instructions. The damage doesn't disappear. It multiplies. Over months, sometimes years, a cluster of abnormal cells can form. Scientists call this a clone, a population of cells all descended from that one original mistake. This is the early architecture of skin cancer. Still invisible on the surface, still silent, but structurally, the process is already underway. Which cancer develops depends largely on which cell type is affected. Basal cells live at the deepest layer of the outer skin. When they are affected, the result may be basal cell carcinoma, the most commonly diagnosed form. Squamous cells form the upper layers. Damage here can give rise to squamous cell carcinoma. And melanocytes, the cells that produce skin pigment, can give rise to melanoma. Melanoma is less common than the other two, but it carries a greater capacity to spread to other parts of the body, which is why early detection is taken so seriously. 3 different cells, 3 different cancers. One common origin: ultraviolet radiation. The good news is that most UV exposure is preventable, and most skin cancers, when caught early, are highly treatable. Seeking shade during peak sun hours, wearing protective clothing, applying broad-spectrum sunscreen, and avoiding tanning beds all reduce the initial UV load your skin has to defend against. And knowing what to look for matters just as much. A spot that doesn't heal, a mole that changes shape, color, or border, a growth that looks different from everything else on your skin. These are signals worth showing to a medical professional. This video is educational only and cannot diagnose any skin condition. If you have concerns about your skin, please speak with a qualified medical professional. But here is what science has made clear. Skin cancer doesn't begin with a diagnosis. It begins with one cell, one break in the code, and a repair system that couldn't keep up. The sun gives life, but it asks something of your skin every single time. Know what it's asking.